Hello, everybody. Thank you very much for joining us today. We're excited to bring you this presentation with Qfree. Just want to make a few notes at the beginning here. If you are on the phone and you need to step away, please do not place the call on hold, but rather disconnect and reconnect at a later time. For Q&A today, we're going to be addressing questions at the end of the event. We're asking that our participants who are on the computer, if you would, when you have a question, go to your attendee area, and near your name there will be a place for you to click on an option to raise your hand. You can raise your hand at any time during this presentation, and we'll do our best to address your questions at the end by calling on those who have raised their hand. We are going to go ahead and get started today by introducing David Mark. David has been in the transportation field for nearly 30 years and has played key roles in major infrastructure and system projects, specializing in ITS, tolling, tunnel monitoring, and control systems. Over the last 10 years, David's concentrated on business development, with focusing on things such as driving expansion of the transportation business in the North American market for high-profile, strategic transportation infrastructure and integrated mobility deployments. Joining Qfree in 2015, David currently serves as the Vice President of Business Development and Product Strategy, delivering integrated solutions for advanced traffic management, mobility, tolling, smart cities, and connected vehicles projects. David holds a Bachelor's of Science degree in Civil Engineering from Northeastern University and has been active in ITS New England, Massachusetts since 2006, where he currently serves on the board of directors. So with that, I would like to hand this over to David.
Okay, thank you, Sharon. With me today also is Jim Alves. Jim is, many of you in the industry might know him. Jim's been involved in image-based solutions now for quite a long time, and he is both the solution architect and our resident expert in image-based tolling. So Jim and I will work the presentation together today. I'll be the main presenter, and Jim will chime in at different opportunities to add some more detail. So just to kind of let you know that. So welcome, everyone. I appreciate the large turnout we have today. This is our title of our presentation is Who Says You Can't Have Both? Image Review, OPEX Savings, and Unprecedented Accuracy. And hopefully today we'll show you and demonstrate to you that you can have both of these. So this is our agenda. First, we're going to cover what our purpose is. I kind of already went over it, but we'll restate that. I'm going to tell you a little bit about Qfree so you understand who we are as a company. We're going to move into the agency goals. What are the agencies interested in? And then talk about the toll collection process and some of the cost drivers that go along with that. Then we're going to introduce you to our Qfree Entrada and Insight and ISS solutions for the image-based tolling, or for the image review solutions in the tolling industry. And then we'll talk about some takeaways, and then we'll do a Q&A period. So this is our purpose. We're going to introduce you to the advanced learning systems, how they can save image review OPEX and maximize revenue for agencies. So just to tell you a little bit about Qfree. Qfree is a global ITS solutions provider. We have a footprint in well over 20 countries in the world. We're based in Trondheim, Norway. And whoops, I'm a little click happy there. And our North American market, we're based, our major offices are located in Chesapeake, Virginia, where we service our interurban solutions and tolling solutions out of there. Our office in Boston, near Boston, Sudbury, Massachusetts, where we have our Parking Guidance and Management Solutions Center. And we're acquiring a company called Intelight. They're based in Tucson, Arizona. They're an urban traffic control or traffic signals control company. We also have smaller offices in Seattle, Washington, Toronto, Canada, Raleigh, North Carolina, but our main offices are the three we've listed here. So this is our portfolio. Just to kind of give you an idea of what we're into. We cover these 5 major market areas. Tolling in particular, in the North American market, we concentrate on image review automation software and manual image review software, the integrated automated and manual image review software and solutions. Our interurban solutions include freeway traffic management solutions. Some may have heard of our OpenTMS traffic management software, where we provide statewide traffic management solutions for many states in the U.S. Integrated corridor management and mobility management solutions, truck parking solutions, and lane closure management. Our infomobility market, we provide cycle and pedestrian counting solutions, way of motion, traffic monitoring and control, and traffic detection devices. Our parking guidance vertical, we bring parking guidance systems, and we service both indoor and outdoor parking monitoring systems, parking garages and on street. And our urban traffic management solutions, we provide traffic controllers on the street, centralized traffic management for traffic signals, ramp metering, and connected vehicles. And we're actually integrating many of these elements together into a more integrated solution. In particular, the interurban and urban solutions are being brought together to provide full corridor management. So we feel like we cover the breadth of the ITS industry. So now I'd like to get into some of the goals. What are agencies interested in video tolling? And if we look at the things the agencies would be interested in, one, in video tolling, they would like to reduce toll leakage. They'd like to minimize that. Certainly billing disputes, those are costly, and also they don't reflect well on the agency. So they'd like to bring those down. Certainly like to reduce manual labor costs. And overall, they'd like to have a reduced OPEX. To bring their OPEX costs or their operating costs down as much as possible so that they can maximize their revenue and their return. So these are kind of the things that agencies are keying in on. Now next, what we'd like to do is to set the stage a little bit, we're going to go through a diagram here and kind of set the stage for the video toll collection process, just so everyone understands all the elements that are involved. And so the video toll collection obviously starts at the roadside where a license plate image is captured, or sometimes not captured. Sometimes it's missed, but that's where it begins. And that transaction is either readable or not readable, as determined by our systems. And so those readable and unreadables go into our transaction review, into the transaction review system, and they can be read or not read and moved along. But those ones that are read, that can be read by the system, can be either automated, which means that there's no manual interaction required, or they need to be manually read by an operator to help the system actually understand what the license plate said. And of course, both of those can be done right and wrong. You know, both systems can be right and both systems can be wrong in their read. And then that moves along to the patron identification. So once you've identified your plate, can you match it to a patron and actually create a correct or an error, but you actually want to be able to create a billable transaction. Now those reads can be what we call a false reject. You can see here, if you look at the diagram, we have the correct rejects in purple down here. Those are ones that were not captured by the system in the beginning. So those are correctly rejected. But the false rejects are ones that maybe weren't read properly by the system because of various things that we're going to talk about later. But those false rejects are really the main culprit and one of the main drivers in what the errors you see up here in red. And so this is kind of the process. If you get it to the billing, you're able to bill the transaction and receive payment. That's great. That's what we're trying to get. But sometimes you have disputes, as you can see over here. Sometimes the patron doesn't agree or thinks that wasn't their toll, and that can actually create some public relation responses or problems requiring more manual effort. Go back to the CSC, the Customer Service Center, and that in turn might have to put it back into the review system to be reread. So that's kind of the life cycle of a transaction in the image review video toll collection process. And so what we're going to concentrate on today is the image review portion of that, the portions that the image review subsystems are involved in. And we've highlighted those here in gray, just to kind of give you an idea what we're talking about. So hopefully that sets kind of the stage for moving forward in our discussion. Now, Jim, did you want to add anything at this point, just in case?
No, I think that's fine. Your errors and false rejects are your primary cost drivers, which we'll find.
They are the keys, correct. And so with the video image, with the video tolling system, there are what we've identified as three major cost drivers, or groups of costs, but really the cost drivers that are adding cost to your system as it moves along. And the three that we've identified are the quality of the input, or the image quality that comes from the roadside, the manual labor costs, where there's operators need to interact with these images in order to have them be read properly or without errors. And what we're concentrating on today is that operator at the console inside that gray box we just showed. So just so for our discussion today. And also the quality of the output, which is analogous to the accuracy. Obviously, that's the goal, to get accurate reads out and build and money in the door for the agency. So these are the cost drivers. So let's look at the quality of the inputs a little deeper here to kind of get an idea what that's all about. And so you can see our diagram here again that we've already gone through. And over where the yellow box is that's where the video transaction that's captured at the roadside enters into the image review system. And really the first thing that we need to accomplish in the image review system is determine whether this is a readable or unreadable image. And so that's kind of where the quality of the input really matters. And those transactions can be readable. If they're readable, then there's lots more we can do with it and actually save costs, fewer touches, fewer manual touches, and also you can bill it to bring in the revenue. So what are some of the things? Jim, did you want to hop on this one? I think it's a good one for you, yeah.
Okay.
This is the garbage in, garbage out slide. I'll introduce it. It's a simple concept. It is pretty much if you get image review that's garbage in, then the output is going to be garbage too. There's really no way around that. And Jim, you want to add something to that?
Well, this is a key part that we see several agencies tend to not focus as much attention on, is actually quantifying what image quality needs to be. And so we're going to talk a little about that on the next slide. But in order to maximize your OPEX savings, reduce your errors, you really do need to pay attention to the image quality in more detail. And there's a lot of factors that can affect image quality. How dirty, how scratched, how bent, how faded, how obstructed, what kind of viewing angles, how out of focus is the camera imaging, how much glare, overexposure, how much noise. All these factors can impact the readability of this license plates. And I put license plates up here that you can't read so that you'd focus mostly on the quality of the image rather than say to yourself, oh, well, I can read that. Remember, there's humans and machines trying to read these license plates. And where do they make most of their mistakes? They don't make them if it's clearly readable. They don't make them if it's clearly unreadable. They make them when it's in between. When the quality of the image starts to produce ambiguity in the possible way to read it. So simply because it's human readable, which is often the only requirement we see in RFPs, is that the cameras produce human readable images. We provide a whole series of quantifiable definitions of what image quality is based on scientific evaluations of what it takes to make both plates readable by humans and by machines. We'll share that with you at some other point if you're interested. But for now, I just want you to note that there are many factors, some of which are under the control of the camera imaging subsystem and some aren't. Some require you to ensure that people are following the law and putting up license plates and mounting them in ways where they're visible, but others require that the camera imaging subsystem not produce blurry images, low resolution images, or overexposed images or underexposed images. And that's where attention needs to be paid. That sometimes we see either in the RFP doesn't quantify that you really need to have image quality that is superior so that it reduces the amount of ambiguity in a license plate. So go ahead and click.
Perfect, perfect.
So image quality, image readability are essentially a flip side of the same coin. If there's high image quality, it's very readable. and it's readable if the quality is sufficient. And it's important to recognize that humans and machines have different requirements for readability. So striving towards a high quality imagery with sharp focus, high enough resolution to see all the little details on the plate is critical to your operations and reducing OPEX. You shouldn't just say, well, let the software or the human figure it out, it's good enough. Really focus on this part. It will help reduce your OPEX.
Perfect. All right, thanks, Jim. So next thing we're going to do is focus in on manual labor now. So what's involved with manual labor? Where's the cost driver? Where are the elements? So really where this comes to bear is the next step in the process where you can either automate or not automate your image, your transaction. Obviously, automated transactions don't require any manual interaction, and of course are incredibly cheap and don't cost you anything in manual labor. But ones that need to be manually read to either provide more confidence or have a problem with some area of the plate, those are where your manual image reviewers are required to come in and help the system. So it's not that complicated, but I wanted to just point that out. But the problem we see quite often is that agencies and others tend to focus on this one element of the system, this manual image review cost, and think that that's your only OPEX cost, and it's really not. It's a cost, there's no question about it. But what we're going to talk about as we move along here is how it's not the overriding cost. It's not the most important cost all the time, and that's what we want to talk about as we move along here. So the next driver is the quality of the output. And so the quality of the output is really about false rejects and errors, because false rejects of images and plates that are incorrect actually create errors in billing and don't get you paid. And so this is where you can lose a lot of dollars in your system. And so this is an area that we want to focus in on as to why this is important and why it's not always correct to just concentrate on that OPEX of the manual image review.
And just to help clarify, because there was a false reject is a readable plate that was input to the transaction review system, but it was declared unreadable, typically by human reviewers, given that they have a fair amount of quick time to hurry up and make their decisions. There was a reject saying this is not readable, and they coded off why, but in fact it was readable if more time was spent, and that's a lost revenue to you. And errors, of course, are readable plates or unreadable plates where they've generated a incorrect answer.
Perfect. Yeah, thanks. Good clarification. Appreciate that. And so what are some of the factors that are involved with OPEX savings? You know, we've talked about the automation rate. Obviously, the higher the automation rate, the fewer touches required by an operator, the fewer manual interactions, and that obviously costs less money. Accuracy is also another factor in OPEX savings. If you have too many rejects, especially the false rejects, as Jim just talked about, and the errors, your accuracy goes down, and those are transactions that you can't bill and you can't get the toll revenue. So those both add up to the total OPEX savings. But what you'll see is that the automation rate or the manual image reviewer costs are actually pennies when compared to the dollars that you're losing when you're not collecting a toll. So this is part of the argument we're trying to make here, is that the pennies you see on the manual image review savings are important, but they're not as important as the lost revenue on the tolls. And that's what adds up to OPEX savings. And we like to show it kind of this iceberg over here is kind of a way to visualize it. You know, the automation rate or the manual image review costs are the piece of the iceberg that you can see, and everyone focuses on that. But there's a whole big part of the iceberg that you can't see, and that's really about the accuracy and the error rates and the big dollars that you're losing on the bottom part of this. So what we want to do is kind of show you what the perception is out there. And the perception is that OPEX savings, that if you increase your automation rate, that you're gonna be increasing your OPEX savings. And that's true to a point. We'll see, because your accuracy also adds to that. You've got your OPEX savings for automation plus your accuracy OPEX savings, where you collect more tolls, where your error rate gets lower, right? Your accuracy rate goes up. And that's the total OPEX savings between those two. But the statement at the top here, where we say increasing automation rate will always yield increasing OPEX savings, that's not true, and that's not what we've actually seen. What we see is more like this, where if you continue to improve automation in the system and you keep going without paying attention to the error rate, eventually the automation will start dragging the error rate down, because you'll get a lot of incorrect reads and errors in the system. The more you try to wring out the automation and not pay attention to the errors, the more it's going to drag down the savings due to accuracy, the red line right here. And that will in turn drag down your total OPEX savings. And there is what we call an inflection point here, where you can kind of see where the OPEX savings due to accuracy start to dip. That's kind of the point where you probably should stop forcing more automation in the system and start concentrating on increasing your accuracy, because that's going to bring you more dollars. And that's kind of what we say here. So that's kind of the argument we're making here, is that paying attention to the accuracy is more important at some point than the automation. And Jim, you want to add anything to that?
No, I think you said it perfectly.
Good. And so here's an example. I'd like to let Jim talk about this, just because he's much more familiar with these numbers. But here's an example from a customer that we actually did a value proposition for. So Jim, you want to jump on this?
Yeah, for several agencies, we've done some reports based on data they provided us, where we could actually calculate the false reject rate and the error rate based on the data they gave us. So we analyzed a whole bunch of transactions they gave us, did an extensive, very detailed manual reviews of this information, so that we could determine when their system produced a false reject, i.e. the plate was actually readable, but their system said it wasn't, or they made a billing error where the final result coming out of their system was a incorrect read. And from that, we also calculated their automation rate with their current automation system. That's the left column here. They gave us information about what their average manual review cost per transaction sent to manual review cost. It was about 3.5 cents here. They had specified an 85% automation rate, which they were getting. We found out their false reject rate was 0.5%, and their billing error rate was 0.37%. And the unbillables that they had, the vehicles didn't have a readable plate on them, either because of the camera or because of the physical condition of the mounting or the plate itself. It was around 2%. We've seen that vary anywhere from 2 to 3% in agencies. They estimated that their average toll charge, i.e. cost of not billing a transaction, was $1.50. And for errors, so a false reject means you didn't bill it, so that would cost $1.50 in terms of OPEX. But an error will cost you more than that, due to the CSC interactions or press dealing with responses to customer complaints and press releases and so on. Typically, anywhere between a factor of 4 to 10 is applied to the average cost of a toll in terms of what an error costs. So you can see there's strong weight factors in terms of costs of false rejects and errors versus the 3.5 cents per reviewing a transaction. Anyway, when you compute all this in the proper formula, it computed that they were roughly getting a 6.5 cents OPEX cost per video transaction, including errors and false rejects, not just the manual review labor cost. And below that's broken down into who was generating the most cost. You'll notice that actually the unbillable transactions was fairly high at 2%. Of the 6.5 cents per video transaction OPEX cost, 3 cents of that, slightly less than half, was the unbillables. Obviously, it makes sense then to go after people and enforce the laws that they have to have a readable plate on their vehicle. But errors was number 2. False rejects was number 3, and look what was last, the manual review cost. per transaction. The reason it's not 3.5 cents is rather 0.5 cent is because a lot of the transactions are automated. Their total operational expense for this 300,000 average daily transaction volume is a little over $7 million per year. If they adopted, and some of these agencies did, the Insight system, notice the automation rate dropped from 85 to 70%. Well, that's heresy in most people's mind. If I reduce the automation rate, I'm increasing my labor costs and reducing my OPEX savings. Well, not really. Notice at the bottom here that the change at the very bottom row, we dropped their OPEX by 27%, even though we reduced their automation rate by 70%. In this particular example, we put in a higher labor rate, 4.2 cents per video transaction reviewed, rather than the 3.5 cents. The reason for that was to accommodate for the fact that in our system, we enforce double-blind reviews. We have a variety of checks. Why? To get the accuracy up, to reduce the false reject rate and the error rate. Notice that those dropped fairly dramatically from 0.5 to 0.1, false reject rate from 0.37% to 0.05%. On the billable rate stays the same because that's more a quantifier of the actual traffic. The traffic had 2% unreadable bills, unreadable plates. The average total charge, of course, stays the same, and the weight factor stays the same. And you can see that the OPEX cost per video transaction dropped from 6.5% to 4.71%. So this agency would realize approximately $2 million in OPEX savings per year by requiring much higher accuracy and not trying to drive the automation rate to near 100%. So that's part of the message we wanted to point out, that you've got to make the right balance and trade-off between automation rate and accuracies. Go ahead.
Perfect. Yeah, thanks, Jim. All right, so now what we'd like to do is introduce you a bit to our Entrata Insight ISS solution, which Jim just alluded to as some of the things that, what we can do with it. And so first, the basic building block of Entrata Insight is the Entrata ALPR system. And that is a roadside deployed system generally, but the interesting part about it is that it's just of multiple OCR engines. And quite often we see in RFPs a desire to have multiple OCR engines in the mix to compare them and to try and get them to work together and integrate them somehow. And that turns out to be a relatively difficult task to do at an ad hoc environment. What we've done is taken our basic ALPR engine and brought in multiple OCR engines. We already do that under the hood. So it's kind of using multiple engines to get you the best result at the ALPR level. So what we've done next is taken that ALPR engine, use it as a basic building block, the engines, and brought them into what we call our Entrata Synergy server. And Entrata Synergy server is our automation backend. It's kind of like the ALPR on steroids to some degree. And it's essentially a cloud-based solution that we take the ALPR OCR engines and we add some patented learning processes and workflows to them that allow us to automate with high accuracy many transactions, and it gets you really very far down the road for automation, high automation rate and high accuracy. But our main solution, which brings it all together, is what we call Entrata Insight, and it builds on Entrata Synergy server, brings that over, also has the ALPR under the hood, and adds an integrated manual image review interface to the mix. And it's got proprietary workflows in it too. And these workflows are integrated with Entrata Synergy server's processes and workflows to get the most efficiency and the most accuracy out of the entire system. And so it's very important. Sometimes, folks think that they're, like for instance, there's a lot of MIRs that have like a single stream of transactions that come at you. And the operator fields a myriad of different problems all in one single stream. They'll be looking at a plate find over here, or a bad jurisdiction over there, or some other thing. What we try to do is compartmentalize that and try to make it so that you get more efficiency out of that operator, more accuracy, because they can look at things in large groups that have certain particular problems with them, and they become very efficient at that. And so our MIR engine is very interesting in its approach. I think it's unique in the industry from what I can tell. And that gets the most efficiency out of the systems. And in some cases, we've been able to demonstrate that our solutions can provide these types of annual OPEX savings, depending on, obviously, there's lots of variables that can go into this. As Jim likes to say, your mileage may vary. However, this is kind of an idea of what you can get and how these different solutions work together to get you the best OPEX savings overall. But truly, the Entrata Insight solution, it provides the highest ROI for the customer.
And the learning processes is key. These are dynamic learning processes, which we'll talk about here.
Right. Yeah, you can talk about this one if you'd like.
Okay.
Yep.
So many OCRs are integrated in a camera or on a roadside right next to the camera, and they typically only look at the tolling zone, maybe only one direction, produce results. Some sort of combination logic is done, and out comes an answer, and then it's fed forward to the host for the central back office. Our experience has been that if you really want to wring out the maximum OPEX savings you can get with automation and learning from human manual review, you need to centralize the automation process. Yes, you can do some of the OCR on the roadside if that makes sense, but more often than not, it makes better sense to move the imagery over to the central process and allow both the ALPR type processing to work on it, the human review to work on it, and this learning processes to work on it. Because with learning, we can see across the entire roadway at a centralized process rather than locating the OCR in a specific location on the roadway. Go ahead and click. So what our system does is it does short-term and long-term vehicle pattern memories. It may not necessarily be able to read the license plate at that particular location, that particular time, but it can memorize where the plate location is, some part of the vehicle, and store this information in a memory. We use advanced pattern matching so that we can send only one transaction per vehicle to manual review. So in this example, same vehicle travels through three tolling points. Potentially, the automation can't read that, let's say. The OCR couldn't read the license plate on that vehicle. Either it wasn't a type of plate it was trained to read, or there's some condition about the plate that makes it difficult for automation to achieve a high accuracy read. In which case, most often, each one of these transactions by current system designs would be sent to manual review one at a time, and they'd have to read 3 transactions. Our system can look across the network and say, the pattern of this vehicle is the same. So this is the same vehicle showing up in 3 different locations. I don't need to send it to manual review 3 times. I'll send one of these to manual review, and then I know to assign the manual review answer to these other transactions because I know they're the same vehicle. In this way, we can minimize the amount of manual review processing that has to be done. At least this is one way to do it. We do a whole variety of other techniques, but this is one way to do it, using short-term memories to say I see it in the same vehicle showing up in multiple tolling points within a short time frame. But we also memorize, when we do get a manual review answer, we memorize the pattern that we saw on the roadway with the actual human answer. So the next time this vehicle shows up, more often than not, we can say, let me check my long-term memory to see if I've already read that pattern before. That's by manual review, and verify the accuracy. If so, then I don't even have to send one of these to manual review. I can just go ahead and associate it with a previous manual review, in which case the system is dynamically learning over time how to read the plates on your toll road, and therefore increase its automation over time, a feature that not too many of our competitors provide. Okay.
Perfect. So next, what I'd like to do is highlight some of the features and benefits of the Entrata Insight ISS solution. And so these are kind of the 4 main feature areas. We have high accuracy, high automation. In particular, what the main benefit of this, but there's others, is it significantly reduces leakage. That's the main benefit of these elements. It also reduces OPEX overall. They're very scalable and flexible. can run locally, cloud-based software as a service if you'd like. The business rules, we have specific business rules, but we understand that different customers have different needs, and the business rules can be modified for their particular needs as necessary. We have, like I mentioned earlier, our OCR engines is a highly tuned cascade, like we call it cascade OCR. We use multiple engines inside of our ALPR. And we also have a highly integrated advanced manual image review system, as I described earlier. And we like to say it has built-in quality assurance. That's kind of what we think is one of its main biggest elements that it brings to the table, beyond all the efficiencies and the increased accuracy that we get out of it. So those are the main benefits of the software. And here's where we're installed right now. Our ALPR engine is installed in many different places around the U.S. And many states that have toll roads have our ALPR engine in it already. But this is where Insight and ISS are deployed. We're in Massachusetts for MassDOT. We're statewide there and have been for a year or so, 2 years. We're in VDOT, I-66 and I-64, our ISS. Go ahead, Jim. I-66 and I-64 and VDOT. For North Carolina, we're in the Monroe Expressway and I-74. We're system-wide in MDX, and we're on the way to being system-wide in CFX as they add gantries. And we're also new ones that are coming online very soon, WashDOT in the Seattle area and Sandag. So this is kind of our footprint right now for our solution.
We should point out that some of these, of course, agencies' installations are in different states of being installed. There is a tuning process involved in delivering these systems, and some of these states, they're in the process of still being tuning finished. But MassDOT and MDX and VDOT have been operational for quite a while and demonstrating that we can achieve 70–80% automation rates at 0.05% error rates or lower, which is saving these agencies significant amounts of money.
Yeah, no, that's great. Thanks for that clarification. Appreciate it. And so what are the takeaways here? Well, we see three major takeaways. As our title belied of the presentation, you can have both high accuracy reviews and maximize your OPEX savings. Clearly capable. We've shown you that that's possible. Keep an eye on the pennies, but focus on the dollars. Increasing automation rates do not maximize OPEX savings all the time. Accuracy is the key, and that's what I hope we've demonstrated today. And also, we feel very strongly, a proven solution with a sophisticated, integrated MIR, learning technologies. We feel that a system like this, which is what we provide, provides the best ROI for the end customer. And so let Qfree help you maximize your OPEX savings. That's what we would like to leave you with today. So with that, I'm going to turn it back over to Sharon, and she's going to open it up for questions, and we'll provide you some answers. Sharon?
Thank you so much, David. Again, if any of our attendees have questions, if you would please hit the raised hand button, and we will do our best to call on you, get you unmuted, and get those questions addressed. If you want to start with one of our questions that was provided was, how does your system perform with stacked letters?
You want me to take that one?
Yeah, go ahead, Jim. I think you.
Yeah, stack letters are common particularly in the Northeast, but a few other states as well. In fact, Maryland was the first state in the nation to create the standard issue plate with vertical stack characters for their 100th anniversary. Our system can read vertical stack characters, again, provided there's a sufficient amount of image quality. Most of the camera systems that are deployed on toll roads today from most of the manufacturers and integrators are delivering enough resolution and sharpness for us to read those characters accurately. In some cases, the double stack characters or triple or quadruple stack characters, like they can appear in New Jersey, are treated as a specific character, as one unit, because it occurs as a fixed value. But in Maryland, those letters, the two stacked letters, they would vary. They start with an A on the top and they ran through A through Z on the bottom, then they switched to B on the top and ran through A through Z and went through almost all the letters that were out there. So that had to be read, not as a fixed, treated as a combination character. And our system works quite well on that. Again, provided that the imaging provides a sufficient quality.
Yeah, and that just belies, just to point out the obvious, knowing each individual state's plates, which are vastly different in some places, is really important in this business, and that's what we excel at. So, Sharon, next question.
All right, I've got a question here from Greg Florin. Greg, we're going to unmute you now and let you ask your question.
Great, thank you. This is Greg Florin with 3M Company. Perhaps I'm not fully understanding this idea that improved accuracy with lower automation rates gives you the better OPEX, which you showed in the chart. I would assume improved accuracy would actually lower the need for manual review and increase your automation rate, but you're showing it differently, and I'm just trying to understand that better.
Well, what we're saying is that what happens when many agencies try to adjust parameters or retune their system to produce higher read rates, what you're doing is you're forcing the system to try to make more reads occur. And that means it's going to try to read more plates that it's not that qualified to read, or is not that capable of reading, or is the characters are such that that particular style of plate is more difficult to read accurately. And what happens is you push the accuracy of the total read rate down. When you push, at some point, when you keep trying to push the read rate higher and higher, something gives, and that something is the accuracy. And when that accuracy falls, the OPEX for the customer is highly sensitive to errors rather than to sending stuff to manual review. And so suddenly you're starting to make a trade-off that actually costs the agency more money, rather than backing off the automation rate so that you achieve extremely high accuracy, and then sending the rest of those transactions to manual review. But you need a manual review process that also produces high accuracy, not only to keep the OPEX down, but to enable automated learning at high accuracy. So that's the reason accuracy becomes a more important parameter than automation rate, actually. Not to say that you don't want to have as high an automation rate as possible. You do, but you want that automation rate to occur at a very high accuracy rate.
Right. Yeah, that is the key. That is the key. Right.
Did that answer your question?
Yeah, thank you.
Next question, Sharon.
All right, we've got a couple of questions here related to some feedback and weather conditions. The first one is, can you describe the weather conditions that affect your levels of accuracy? For example, levels of snowfall, degree of rain, fog, smoke.
A lot of that has to do with the quality of the imaging system. Most weather situations at a 50 to 75 foot distance isn't that important. Where snowfall causes a problem is when it's in the condition where the snow begins to stick to the license plate. You've got that transitional weather where it's starting to freeze but isn't quite frozen yet, as the cars in front throw up a lot of dirt, the tires in back throw up a lot of muddy water that freezes on the plate and begins to make the plate unreadable because the contrast begins to fall. At some point, of course, you can't deal with it. If the plate contrast is too low, it's not going to be imaged well, and therefore we're not going to be able to read it, and neither is a human going to be able to read it if it's bad enough. So most of the time, though, we've seen in these, but we have systems running in Toronto, we have systems running in Massachusetts where it snows, and they put salt on the road, and they create this condition where you get dirty water that freezes to parts of the car. It's a fairly rare enough event that it hasn't caused them a significant cost problem. But it is something, of course, that you can't deal with in the back part. If the license plate is not of a condition that makes it readable, then you can't possibly read it. But in practical experience, that's not a major issue. Raindrops and snowflakes are out of focus for most of these systems. and therefore they don't impact the image quality of the license plate.
Okay.
Did that answer you?
Yeah.
Okay.
Go
All
ahead,
right, our
Sharon.
next question is, does your system provide specific feedback when image quality falls below the minimum image quality required? For example, knowing when a camera is not focused properly would need to be corrected as quickly as possible.
It turns out that is, there are several ways to try to measure image quality. As I mentioned in one of the slides, image quality and readability kind of go hand in hand. So there are human reviewers that are looking at some of the imagery. They'll identify through code-offs when they see poor quality imagery. In an automated fashion, we can see the automation rates begin to fall in individual camera locations or plaza locations. That's an indication that there's something potentially awry. Completely automating the process of identifying image quality is somewhat difficult, because in order for a machine to identify the license plate, where it is and what's on it, it has to have a certain quality in order for it to do that. As the quality falls, it becomes more difficult to identify plates and information on the plates to then make the quality measurements. But we actually have been working quite a bit on that, and we do have some techniques. We have automated image quality measures that we produce inside of our OCR that are then delivered to the ISS, which then generates reports that gives you indications of image quality. But there are more alarms telling you that you need to look here. There's something different about this camera versus that camera in your system.
Right, and we've actually been able to use our system to help the agencies and the integrators know when they have camera problems, because we start to see it. It starts to show up in our system. We say, hey, you might want to go look at this camera. It's got a problem because we're not getting the output that we were earlier or some other time. So it's very useful in that way. Next question.
Our next question is, what specifications do you recommend to ensure high quality images are captured?
What we should do is get your name and send you, it's a fairly, you know, I can't answer that in a few sentences, but basically in any imaging system, sharpness, what's called sharpness, what's called contrast, those are the two primary things that you need to produce on for the information areas on the plate that are required in order to get a correct DMV lookup. And in many states, the license plate read is a fairly complex effort. You need to identify some small print to know exactly what plate type it is. Some of the characters can be very similar looking, B's and 8s, Q's, D's and O's. Therefore, the resolution / sharpness of the image needs to be high in order to be able to make accurate determinations between them. So it can vary from state to state, and it can vary from agency to agency as to what you need. But we've generally created a set of license plate image quality measures that can be done independently of our system, so that you can decide that your camera supplier is meeting a requirement that will allow accuracy to occur. So we'd be happy to share that with you. We put it in all our quotes and our responses to RFPs.
And just to add to that, Jim, it's even more complicated. For those on the phone, I know many of you are in the industry, so you probably already know this, but the complexity of license plates in the United States from state to state is out of control, as we all know. There are hundreds and hundreds and hundreds of different plate types, styles in every state. And we have your system doesn't only have to capture the image properly, it has to actually resolve that plate down to its proper plate style in order, in many cases, for billing purposes alone. And so understanding that from state to state to state to state is a very important part of our business. And so our system, we constantly keep that up to date, and we're constantly adding new plates, and because they're always adding them and so forth. So it can't be minimized that's a very important part of the entire solution. So
we've provided to several consulting agencies recommendations for how to specify image quality, and we know that some agencies have actually adopted that and put it in their RFPs.
Yes. Anyway, next one, Sharon.
The next question is, you mentioned quality assurance for the manual image review. What specifically ensures the quality of the manual review?
A couple of things. We took a detailed analysis of what causes humans to make mistakes when they read license plates in high volume, like applications like we're doing here. And what we found was, of course, the fat finger problems, typographical mistakes. And so you must use a double-blind review. And double-blind review meaning that you put up the image of the license plate and you don't show them what somebody else thought the license plate read was, because that skews the reader into seeing something similar to what somebody else saw. We see that mistake done all the time. Yeah. But so double-blind review is one key aspect. It gets rid of typographical mistakes. But to get error rates even below that, we identified that it wasn't just typographical mistakes. There are a fair number of correlated errors, meaning two different people can read a plate incorrectly the same way, and therefore double-blind review checks won't find that error. What's causing those errors is the ambiguity that I talked about, where it's in between readable clearly and unreadable clearly. It's somewhere in between. And these people aren't going to spend an enormous amount of time sitting there trying to read a license plate. They're going to type in something and move on. So we have a training mechanism. We teach them what to look for in an image before you jump to the conclusion. That forces their mind to look at the right information to see if it's ambiguous or not. And then we also have to check to see if they're doing what we told them. And what we do that is we have a patented process called probes, where we inject into the flow of reviews certain types of license plate imagery that we know is ambiguous. But we know that it's clearly readable if you are looking for the right things in the image. And the computer interjects these things at a programmable rate, and we can measure whether they are paying attention to what we call perceptual errors. And if they aren't, then the batch of reviews they've done for us, we move to somebody else who has done it correctly, their probes they've successfully done, and we alert their supervisor that this person needs to be reminded what it is they're supposed to be doing and looking for in imagery to make sure they produce highly accurate results at a high efficiency rate. Lastly, what we've now determined, and the industry produces much higher accuracy with automation than it does with manual. So now the concept has flipped. It used to be in the old days, you sent things to manual if you wanted accuracy. Now the job is to send as little as you can to manual review. And that doesn't mean automating the plate fully. Automation can partially automate a license plate. It can maybe determine the jurisdiction, but it's not sure about some of the characters in the registration, or it's darn sure about the registration, but it's not quite sure about the jurisdiction, or the plate type is potentially indeterminable by automation at the accuracy we're asking it to do it at. And therefore, we focus the attention of manual review. We don't ask manual reviewers to read the whole plate. We only ask them to fill in the missing information that automation couldn't do. If it turns out it couldn't read anything on the plate, well then of course manual review has to read it all. But more often than not, it's only one piece of information or another that needs to be filled in. And therefore we don't ask manual review to do any more work than is necessary. And we develop specialized cues that allow reviewers to focus on providing only certain types of information on the plate, and we see that their accuracy goes up because they're not being asked to do a whole bunch of different tasks and remember which part they have to do and enter all kinds of information, giving them more opportunity to make mistakes. The less we give them to do, the better. The more focused we give them actions, tasks to do, the better. So the whole design of how manual review is done is radically different for our system than it is for most other image review plate read systems.
And Jim, it can't be overstressed that it's much easier to train new operators on our system than it is on most systems, because we can limit the complexity of the problems they're trying to look at the beginning so they can be brought along gradually. And I've actually heard
not only that, in our system, you get graded and trained to certain levels. You achieve a certain level on certain types of plate styles. Our system in automation tries to help MIR as much as possible. So we'll only send certain plate styles to people who have been trained to read those. If you give random plate styles to people, you'll get answers, but they're not right because they're not aware of all the nuances of certain plates. So by focusing the training and limiting what imagery or what plate styles you give people to read, you improve the accuracy of the whole system. So it's a fairly complex design here to try to maximize accuracy in the manual review side.
Good. Next question, Sharon.
All right, we're going to take one more question, and I do apologize. We've actually had quite a few more questions than we'll have time for today. So before we take this last question, I just want to say if we were not able to get to your question, please send it either to David or you can send it to ATI, and we'll make sure that it gets to him. If you were able to send in your question on the chat screen, we will send that information over and have everyone get in touch with you to answer your questions if at all possible. But our last question for today is, does Qfree offer a cloud-based solution?
Absolutely. All of the products we have for automation and manual review can be hosted in the cloud, and we have customers that actually do that.
Yeah, that's actually becoming quite an important part of our business. Certainly, the United States is starting to get caught up on that, but certainly other parts of the world, they're very interested in the cloud solution, and we think it's really starting to catch on here. For those, oh, go ahead.
There are processes built in to help improve security.
Yeah.
Go ahead.
And I have on the screen right now, if anyone wants to get in touch with me, if maybe you can take a screen capture or a picture of it, you can get a hold of me this way. So if you want to send your questions directly to me, feel free to do that.
All right. Well, thank you both for your time today. Thank you to all of our attendees for your time and for your questions and your attention. We look forward to answering some of the questions that you have, and we thank you again. Have a wonderful day.
All right. Thank you, Sharon.